Um, so basically, this presentation overall is about how any domain and all practitioners can create data models in this same way. Um, TLie has a life cycle specification, and overall, it's for the setup and delivery of telecommunications data in this case. And by doing this, it allows objective testing and so forth. And this is the minimum requirements found to be utilized throughout the full project life cycle of telecommunication sites. So the overall problem is throughout all of these years, information has not been captured like we can capture it today, whether it's paper-based drawings that are lost or non-existent or whatever. So when it's time to create the new generations of sites, like the 5G sites that are being built now and 6G sites that we're planning for, it would be great to have this information, but instead we're having to use laser scanners and all sorts of things to collect this information. So the overall objective is to structure this data while we collect it, create it, and store it, and of course, test it and make sure it's usable throughout the full journey into the future for these sites. Within this domain of telecommunications, the overall objective, due to carbon emissions and everything else, is to reduce site visits overall. So how do we reduce the site visits on a global scale is a incentive for the research itself. So you can imagine on the left-hand side there, you have hundreds of thousands of networks, millions of sites all over the world, and you're having to design each of these to have new 5G equipment, and you're having to procure equipment and send equipment, and you would like to reduce the amount of site visits to go and collect this information, right? Well, with TLie, and now that it's been deployed, we have systems that are using this structured data on all major continents. An example on the right-hand side of the main solutions would be the structured data throughout the Americas, through Europe and Asia and the UK. And all of this data is connected and interoperable via TLie, this new data model. So at the outset, the journey began in about 2015, but really kicked off in 2019, was the need for new methods and tools and processes to capture and validate this information for these new 5G retrofits. So, of course, we're leveraging off of many ISO standards, and IFC being the backbone, but the systems that are being built are also catered to ISO 19650 processes and so forth. And this is so we can all communicate and sing from the same hymn sheet globally. And with these processes and further information modeling, we start building the overall ability to use the data model. So one of the main problems is actually a real estate problem, which particular owners own sites, and many different vendors place equipment on these sites. And there's available space, but where is this available space? Is it structurally sound for the new equipment? And it's hard to make all of these decisions when you don't have any information to go by. So very simple problems that should hit home easily and resonate with you would be, imagine having to procure cable to go out to one of these sites in the middle of nowhere. Use your imagination. And you're sending out big spools of cable like this, and there's so much waste on all of these sites where they're either unused cable or empty spools of cable or just sitting there. And over the decades, it's become quite a problem. whether it's on the site where we have cabinets that are unused out in bogs in Ireland, and the new cabinet is sitting right next to it and the old one's just sitting there decaying, or if it's in rooms within airports, similar to on the left-hand side, where you have the old equipment sitting side by side with the new equipment. And it's not a good scenario from a waste perspective or planning and going into the future. So the overall goal is to know exactly what equipment is being used, exactly where it's located, how is it connected, and then by having that information structured within systems, we can query that data for many reasons, which we'll talk about later. So in a nutshell, a communications site is similar to what you see here. You have an old legacy node, 2G or 3G or 4G, which still could be in service. And the objective is to put the new equipment there, but it can also share the older generation's equipment. And how do you make these decisions if you don't have any information to go by, right? So if we're talking about millions of sites, can we really send people to millions of sites to check existing equipment for the new designs? It becomes a very difficult problem to solve. So we have leveraged off of open BIM standards and created the data model and many data schemas to exchange teleformatted data. And we're seeing a whole new world similar to, on the left-hand side, you can imagine how sites, I know it's a drastic example, but this is reality, that equipment is just being piled on top of each other to the point you do not know what's actually able to be used or what's in service. And then on the right-hand side, imagine a much more leaner process and outcome. So again, before using the TLie data model on the left-hand side, and then you can imagine a very cleaner and more elegant delivery. So the objective is to create lean processes throughout the full project lifecycle, so we can design, build, and operate using the same information, and we can specify what information within the data model is utilized by whom, and how do we capture the relevant information from them that's needed going forward. So the way you do this, using open BIM processes and IFC in general, is within the box. If we have IFC there, which is the universe of IFC, everything possible IFC. And with the new 4.3 standard, you can see everything from waterways to tunnels to bridges and everything. So how do we choose what's relevant to our domain? So to box everything in for the telecommunications industry, there were several model view definitions in existence that we can leverage off of. And then there was the parts about TLie that were not within these other model view definitions, and they're unique only to the telecommunications industry for these very specific telecoms purposes and needs. An example would be the connections of cables to equipment. You can imagine an antenna having 8 ports and knowing exactly what cable is connected to which port, and within that system, how do we know what other radios and other pieces of broadband equipment are connected all together, right? So this is how we do this. We travel through these systems using distribution ports within the semantic model. And you can read the slides in the paper yourself for more information. We only have about 15 minutes, but that was the conceptual schema. So once we can conceptualize everything we need about a domain, and we can begin solving the problems. So we begin solving these problems by creating what's called logical model schemas. So some of these standards might be familiar, they may not be. Basically, these are just formats for data, same data, different format. IFC in general, to date, has mostly used the Express data model. We're moving to UML, but story for another time. But that's ISO 10303 step part 11. And the step standard has many different affordabilities to us for the exchange of step physical file formatted data, which is what the so-called IFC file, right? And these are just formats for how do we exchange the data. But then we get much more granular on very specific disciplines and their data within these formats as well. And then we need to create more different types of schemas for humans to be able to read. Not everyone's going to dive deep into a step physical file. So that data and spreadsheet physical file format leans itself well, especially when you're having large group meetings, especially online, and everyone can have a version of this schema and highlight things that are relevant for the conversations. And then we also have the same data in other formats like JSON for the machines to be able to be produced, like new systems like you'll see here, or legacy systems. So literally, how do we connect each of these systems in an interoperable way using this data? So that's exactly what we do. We format this data and we send it to other enterprise systems and vice versa. So the underlying methodology here is ISO IDM, which is the information delivery manual. So how do we specify the delivery of specific requirements throughout the full life cycle? So if you read the paper, you can read more about this. But in the middle, we have 3 swim lanes. One for the design phase, one for design applications, one for basically web-based design review applications, and then on the right-hand side we have mobile applications, all using teleformatted data, and going down the business process model there are the different phases. And we have a site surveying phase, we have a design phase, an installation phase, and an operations phase. Okay, so what we need to do next is take the teleformatted data and allow actors and their processes to be mapped to this information so they can exchange it and we can collect it from them. And then we also build software applications based on these exchanges of this same information. Okay. And we get very granular. By now, we have boxed in all of the IFC data that we would be using for telecommunication sites. And then we have subset schemas for each of the individual exchanges through install, design, whether it's site surveying, and so forth. So each one of these exchanges have their own business process model where we go ahead and do value add analysis and make them as lean as possible. And then we build systems or interoperable exchanges based on this data from these business process models. So next we build the solutions and map them to each of the exchanges, and throughout the whole life cycle, now we're able to use those systems and set up that data and capture that data. So in the end, we should have the information model from the bottom up, model view definition, software solutions, exchange requirements, and then the actual deployment, like we have in the case of TLie here. So what this affords us to do is to create object libraries where we can use pre-designed data already embedded and validated within the objects to simply create models and drawings. Because it's based on open standards, you can use whatever applications you would like to use. In the beginning of the design process, these objects are created. They're automatically checked and validated using online systems like OpenOp from BIM and Scan. The process is use the objects to create the site models, create the drawings, verify and validate the data, and then deploy it to a web-based system where it can be shared throughout the rest of the life cycle for the build. During the install phase, we can automatically now create installation documents from that data within the system, and we can deploy it to mobile devices on the site where we can use BCF API to communicate site changes and deviations and all of these things back into the model. So after the site install is conducted, then we need to update the site models, the drawings, and then we finally have a digital twin. And we have this data that we spoke about in the beginning that we can now use going into the future for all of the telecommunication sites. We also have other validations tools within OpenOp, like BIM and Scan, AutoCore for during the early phases where we're laser scanning the sites and trying to find out how we're going to use what's on the sites for the new designs and builds and so forth. And I know that was a lot within 15 minutes, but thank you.